Hi everyone! Today we'll go through Newton's second law of motion, which is about force. Before that, let's recall back what you have learned before. Do you still remember what is momentum? What is the definition of momentum? Momentum is defined as the product of mass and velocity.
What are the objectives of today's lesson? There are two objectives, which are to define force as the rate of change of momentum,
The first
and
one is
to
to
solve
define
problems
force
using
as
F
the rate
equals
of
to
change
ME.
of momentum.
Later on,
And the
you will
second
know.
one is to solve problems involving F equals to ME. Later, at the end of the lesson, you will be able to know. Next, what is force? What is force? Have you heard of force before? Have you experienced force before? When do you experience force and where do you experience force? Force is actually, let's check it out together. How about a storytelling? Imagine a person driving a car on a road and he wants to overtake another vehicle. What would he do? He would press the gas pedal so that his car will accelerate enough to overtake the vehicle. When we talk about acceleration, what is involved? Yes, that's right, velocity. When there's acceleration, there's a change in velocity. When there's a change of velocity, there's also a change of momentum. That's right. To accelerate the car, the person has to press the gas pedal hard. So what kind of physical quantity involved here? It is force. So when he applies more force, the change of momentum increases. And this action happens within a period. Hence, we can conclude that force is directly proportional to the rate of change of, and this is the Newton's second law of motion. Newton's second law of motion states that the rate of change of momentum is directly proportional to the force and acts in the direction of the force. So what does it mean? It means that the rate of change of momentum is directly proportional to the force. When the change of momentum is higher, then the force will become higher. Or when force is higher, then the change of momentum is higher. When force is lower, then the change of momentum also lower. And the change of momentum acts in the direction of the force. If it's on the opposite side of the force, what happens? It will be negative. That's all. Next. So let's look how we derive the force directly proportional to the rate of change of momentum. So we know that force is directly proportional to the rate of change of momentum, where force is directly proportional to the final momentum minus initial momentum per unit time. And using mathematics, we can find that force is directly proportional to mass and the product of change of velocity per unit time. Do you realize that V minus U per T is actually final velocity minus initial velocity per unit time? Does it seem familiar to you? Yes, that's right. This is actually acceleration. So hence, we can write this equation as force is directly proportional to the product of mass and acceleration. So that is one way to get the relationship between force and mass and acceleration. But there is another way. So another way to get the relationship is by doing experiment. Just now we found using mathematics. This time is from conducting experiments. So there are experiments. Look at the first one. The first one is to find the relationship between force and acceleration. By carrying out an experiment keeping mass constant, we can get the relationship between force and acceleration. So what does it mean by keeping mass constant? It means that mass remains the same throughout the experiment. So when mass is doesn't change, force and acceleration change. When force is increased, acceleration also increases. When force is decreased, acceleration also decreases. Therefore, from this experiment, it's found out force is directly proportional to acceleration. Another experiment is to find the relationship between mass and acceleration. By carrying out an experiment keeping force constant this time, we can get the relationship between mass and acceleration. So this time, force is kept constant. Force doesn't change, force remains the same. So only mass and acceleration change. So when mass is increased, the acceleration decreases. When mass is decreases, acceleration increases. Therefore, it's found that acceleration is inversely proportional to mass. And this time, when we combine the two experiments together, the results of the two experiments together, found out that force is directly proportional to mass and also acceleration. Isn't it easy? Now, this time, we need to write down the proportionality into an equation. Just rewrite the proportionality in an equation. So, we already found that force is directly proportional to the mass and acceleration. This time, we can rewrite it as force is the product of mass and acceleration with the constant k. Okay, now, if we change our force into 2 Newton and mass is 1 kilogram, then from the experiment, acceleration will adjust itself and we will get 2 meter per second square. Can you see or not? So from there also we still get constant k equals to 1. Or another situation, if force equals to 1 Newton, but this time we change the mass to 0.5 kilogram, let's say, the acceleration will automatically become 2 meter per second square. It's law of nature. So from there, we still get constant k1. Can you see or not? So this equation, F equals to ma, we can use it to solve problems. We can apply it in many situations. So now, first situation. So a box of mass 150 kilogram is placed on a horizontal floor with a smooth surface. Find the acceleration of the box when a 300 Newton force is acting on the box horizontally. So from this story, we already know that there's a box with a mass of 150 kilogram. So that's the first information. We already know the mass. Mass is 150 kilogram. And what is another information that we know? It is placed on a horizontal floor with a smooth surface. So we don't need to take anything else into account like friction force or anything else, okay? Because it's smooth surface and horizontal floor. And find the acceleration of the box when 300 force is acting. So from that, another information that we get is the force. The magnitude of the force is 300 Newton. And the story is asking for the acceleration. Can we find the acceleration? We already have force, we already have mass. We can substitute into the formula. So applying F equals to ma, we can get acceleration equals to force per mass, which is 300 Newton per 150 kilogram. So from there, we can get acceleration equals to 2 meter per second square. Therefore, the acceleration of the box is 2 meter per second square. Can see or not how teacher substitute all these values into the equation? Make sure you have the units. The units are so expensive. We need to include the units every time. Understand? All right. So now, look at another question. An object of mass 50 kilogram is placed on a horizontal floor with a smooth surface. if the velocity of the object changes from stationary to 25 meter per second in 5 seconds when it's acted by a force, find the magnitude of the force that is acting. Okay, so how do we solve this question? So first, let's extract all the information that we know from the story. So we know from the story that there's an object of mass 50 kilograms. So that's the first information that we know. The mass is 50 kilogram. And again, it is placed on a horizontal floor with a smooth surface. Okay, and we know that the velocity of the object changes from stationary to 25 meter per second. So what does it mean by stationary? Stationary means the object doesn't move. So what is the velocity then? The velocity is definitely 0. So the object changes from 0 meter per second to 25 meter per second in how many seconds? In 5 seconds. So from there, we already know the initial velocity, which is 0 meter per second, the final velocity, which is 25 meter per second, and also the time taken, which is 5 seconds, and is acted by a force. So the question is asking for force, the magnitude of the force. Okay, to find out the magnitude of the force, what formula can we apply? We can apply F equals to ma. But do we have F? Yes, we do. But do we have a? Do we have the acceleration or not? We don't have. But can we find it out? Since provided that we have the initial velocity, we have the final velocity, and we have the time, can we find out acceleration? That's right. Applying the concept of acceleration, which is the rate of change of velocity, we can first find the acceleration. So now, let's find the acceleration. Acceleration is the final velocity minus initial velocity per unit time equals to 25 meter per second minus 0 meter per second per 5 seconds. And this will give us 5 meter per second square. Remember to write down the unit. And we can next use force equals to the product of mass and acceleration, which is 50 kilograms times 5 meter per second square, make sure meter per second square, equals to 250 Newton. Therefore, the force acting is 250 Newton. That's how we do it. Isn't it easy? Okay, so that's all that we have learned today. Let's recap back what you have learned today. So first, you recall, you need to know what is Newton's second law of motion. What is Newton's second law of motion? Is force directly proportional to the rate of change of momentum, and then derive it to get force directly proportional to the product of mass and acceleration, and then we rewrite it in an equation. F equals to kma, and then we get the constant k, and finally we get the formula F equals to ma. Okay, so we can already apply the F equals to ma to solve problems. Isn't it easy? Yes. Okay, good job for today. See you in the next class. Bye.